So it's our third day now, right? So we have our first lecture on the third day, that is carbon-based startup, a way forward towards bio-circular hardy-based economy. So this will be delivered by Dr. WANI. WANI is a young scientist here, awardee. He has received it from Department of Science and Technology. He has done PhD in soil science from SKUAST, Kashmir only. He is founder and CEO of Kashmiri Cargo Zone Private Limited. He has a very vast experience in this field. So I know him personally. He has always been a brilliant, in studies. So that's the reason that he got this Young Scientist Award. So there are very rare people who get this award, right? But there is a tough competition for it. So I hope this lecture will be very fruitful to you, and please interact with the participant, this speaker. Sir, please. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Thank you very much, sir. I am WANI. Next slide. Slide, excuse me.
Which one here?
So, I will be speaking today before you about carbon-based startups and about circularity in economy and about our horticulture-based economy that is mostly present in Kashmir conditions. Before going to further slides, I will first like to take your attention towards this term biocircular. Actually, there are two types of production systems in the world. One is linear system of production, one is circular system of production. In circular system of production, as the definition states that it is that type of economic system which is designed to minimize waste. Actually, in circular system of economies, we utilize the byproducts, the waste products, to again utilize more products. It's like a cycle, like we don't waste anything in this type of economy. That is known as circularity. If we take example, for example, we have one crop, so we are cultivating that crop in a field. At the end of that crop, there are some residues. There is one option that we will destroy these residues and take the food to our home. So it will be a linear system of economy. Second option is that we will recycle those wastes. We will recycle the food waste also. So the recycled food waste will be this nutrient-rich manure or something like that. We will put it again to soil. It will replenish soil nutrients. By that, the nutrient cycle and economic system will be in a circular fashion rather than in a linear fashion. In a biocircular economy, we also have circularity concept, but it is mainly concerned with the biological entities. Before going to this thing, this is my expertise about carbon sequestration and carbon cycle. Before understanding the carbon sequestration, we have to look on the carbon cycle. There are various cycles in the world: phosphorus cycle, nitrogen cycle, and water cycle, carbon cycle. Same is like carbon cycle. It is also in a cyclic approach. There is one rule in physics: energy cannot be created, not be destroyed, but it can be changed to one form to other form. Same is the case with carbon. You cannot create new carbon in this world, or not you can destroy. For example, if you are burning something, it will produce carbon dioxide. It will be in the atmosphere. That carbon dioxide will be reacted with water. It will make sugars and oxygen during photosynthesis. Those sugars will be stored in plants. And when that plant will dry up, it will again be burned and again be released carbon into the atmosphere. So this cycle goes on. This is known as carbon cycle. So there is one concept here that is known as carbon sequestration. Carbon sequestration is that when we hold carbon for some period of time in some entity, it is known as carbon sequestration. It is very important for climate change mitigation. As you all of know, that carbon dioxide is a major player in the climate change, as it's a greenhouse gas. It traps infrared radiations and causes global warming of the earth. So trapping that carbon dioxide for some period of time in soil or in some entity is very beneficial for climate change. So this is known as carbon sequestration. Biocircular economy. There are some components in the biocircular economy that we have to take into account. This is one circular diagram that will be make clear to you that how biocircular economy is working and what are the processes and factors that are involved in these type of economies. So this is about biocircular approach. Before going that, I will talk to you about that I am addressing to achieve and solve. As you know, Kashmir is a horticulture-based economy. We have 1.67 lakh hectares of land under apple cultivation, and we produce 25 lakh million tons of apple, and we export 20 lakh metric tons of apple every year. This comes at a cost because at every crop cycle of apple there are 14,86,300 tons of crop residues produced from pruning waste every year. As you see from here, this type of heaps are very common in every orchard, in every place in Kashmir. So traditionally farmers simply go for open burning, as you saw like this. You will see in the autumn season mainly they burn all these residues in like this fashion in every field. So it produces 26 lakh 75,340 tons of carbon dioxide every year in Kashmir only. So this is adding up every year. So you can have an assessment how grave this problem is going to be in near future, and already it has been creating problem because there are so many respiratory issues and other issues in Kashmir happening. It is all because of air pollution. As there is one study done by this at Kashmir University, they found that 4 to 5 times higher black carbon was found in winter than summer, which is mainly due to this burning. These are our main two issues that we are addressing. One is our dull, one of the bead in the dull, and this is our apple prune residue. So this is our model of residue management. Traditionally, farmers are either using these residues for cooking or heating purpose. That leads to more carbon footprints and less energy footprints. In our novel approach, we integrated cooking, pyrolysis and heating in a single assembly using system approach. It reduces carbon footprints, energy footprints and also water footprints. So this is our novel approach, and this approach was appreciated by Indian Patent Authority. Luckily, we got patent granted on our innovation, this IoT-based multipurpose pyrolyzer cum cooker. This is the first PhD patent in SKUAST Kashmir since inception of SKUAST Kashmir. So these are our products. These are some of the secondary products that I have developed from the biochar that I developed using our prototype. One is carbonizer, biowasher, carbo-alkalizer and biocarbon. These are some of the amendments that we use in agriculture for various treating various issues in soil. So this is some of the work done that I have done till date. We have characterized fully this our product developed. We have done some structure, some imaging and EDS mapping, and also we have done Newton characterization of our samples. So this is functional group and thermal stability analysis of our products. It indicates that it has very this recalcitrant nature, that it will last for hundreds of years in the soil. Hence, it is very beneficial for carbon sequestration in soil. These are our field experiments at Faculty of Agriculture, Vadodara during my PhD degree program. So I have tested intensely these products on soil and its effect on maize yield and soil health majorly. These are some of the scenes from our fields and our lab analysis. And this is the neutral characterization and proximate and ultimate analysis of the products developed at two different temperatures. It indicates the significance of pyrolysis temperature in quality of biochar produced. This is some of the characterization result of proximate analysis that we have developed at different temperatures, and this is the neutral characterization and proximate analysis of dull bead. biochar produced at two different temperatures. These are some of the variations. And these are the results that we derived from application of these products in our field. This is the variation in soil pH. As we know that Kashmir is a mostly hilly terrain, we have a problem of soil acidity. Because of hilly soils, there is a leaching of salts in high plains. So by leaching of salt, there is a creation of acidic soils in these areas. So soil acidity is one of the major concerns in Kashmir. Our product is having pH of 11.70 pH value. So when we applied these type of products in acidic soils, it proved a very beneficial role for soils in nutrient availability. So this is electronic conductivity variation in our different amendments applied. This is the variation in CEC, cation exchange capacity. It's a very important parameter for governing nutrient availability in plants. And this is 2-year interactive effect of soil pH under different amendments and different rates applied of our product in soils. And this is the variation in soil EC produced and CEC also. These are some of the physical properties that are varied by application of these types of. These are soil porosity, various soil. Actually, there are various mechanisms by which our product mainly this controls soil chemical, physical and biological properties of the soil. It also enhances water holding capacity and aggregate stability in soils. It was very clear among these 7 types of treatment that we have given. It enhances soil aggregate stability. Hence, it has a potential to induce soil erosion resilience in our soils, as I have published recently one publication related to this. This is about maximum water holding capacity. As maize in our Kashmir condition is mainly rain fed, we don't have irrigation facility. So if there is a cessation of rainfall for some period of time, so there is a lot of loss in maize yields in those areas. If any amendment is having maximum water holding capacity to increase that capacity, so it will be very beneficial to boost these yields in maize. So it was having very good effect on maximum water holding capacity in our soils. Hence, it also have very good effect on yields, as we will see in later slides. This is hydraulic conductivity. You will not be much aware about those parameters, but the concept of the idea of those all parameters that we have reported, that it extensively improved soil health in Kashmiri conditions. It was first field trial at temperate Himalayas that was done using these type of products. So we were very skeptical about these results. We also checked soil biological activity by dehydrogenase, urease and protease enzyme activity. It also, you can see the variation among the different treatments. So we studied various mechanisms actually that were governing these biological activities. These biochars increased water holding capacity in soils. So it provides more beneficial environment to soil microbes, and it also gives space, proper space for microbes to thrive on them. So it increases these enzymatic activities related to urease. And these are our field results of crop yields. As you can see, there is 45% increase in maize yield as compared to control. It was very phenomenal results that we got. There were various hypotheses that we drawn at the start, how these much variation in the yields were possible by using these products. One hypothesis was that it corrected soil pH, so nutrient availability enhanced abruptly. It also improved yields. One was water holding capacity. So it is a very limiting factor in rain-fed areas. If any product increases your water holding capacity, so it will enhance yields automatically. And also it improved soil microbial health of soils. So that these were some of the reasons that were responsible for so much variation in the crop yields in our study area. These are some of the papers that we have published in recent years. over carbon sequestration. These are some of the more papers that we have published during my PhD program on residue management and carbon sequestration. This was first paper from here in Royal Society of Chemistry on residue management, that we have designed a one energy efficient, economically feasible and environmentally robust integrated farming system. It was a collaboration of almost 21 ICAR institutes. So these are my contacts. You can reach out to me for any help.
Thank you, sir.
Thank you.
Students, want to interact? Students, may please interact. See, this is a new kind of, these are new things that are coming up now, carbon sequestration and all. So, with this aspect, you want to ask anything?
About climate change, carbon sequestration.
So this is going to be a new area now. This is why we need to do. Carbon sequestration is very important because now there will be, taxes will be paid by states or countries for producing more, have more carbon footprints. So we have to manage our carbon credits accordingly, carbon footprints. So
There is one There is one agency that is mostly connected to United Nations. There is a concept carbon credits. Carbon credits is that if you are able to sequester more carbon in the soil or any entity, you will give them records and they will give you money back for credit. For one carbon credit, they will give you this funds for that. So this is going to be a economically sound sector in future. If you are able to sequester more carbon, you will be earning more carbon credits, and that country will be getting more funds from international organizations. Thank you.
Yes, sir, thank you so much. Actually, as I told you that this is going to be a new area now. We need to work in carbon footprints because states or United Territories or even countries would have to pay more taxes if they are producing more carbon footprint. And as you know that as well, Paris Agreement 2015, our country has also agreed to reduce this carbon footprint. So by 2070, we are expecting to be carbon neutral. So carbon neutral, it's a very challenging task, but we need to start it from somewhere. So like WANI told you about the carbon sequestration process or how they are doing it. So in every process we need to go for it. Like for example, I told you that nowadays we are going for the novel kind of techniques and all, video techniques in food processing. But now we need to go for evaluation of this energy or exergy analysis, or we need to go for how much carbon footprint it is producing, how much water footprint it is producing. Then we need to accordingly modify our technologies so that we can reach that set goal which we have set that by 2070 we are going to be carbon neutral. Like for example, now in fuels we are adding bioethanol. Ethanol is being added to fuels now from last year. So that's one such step towards that, because we have to reduce the greenhouse gas emissions. So in this aspect, this was very informative lecture. But if you need any sort of further information, I can provide contact of WANI. You can get connected to him because he has a good experience in this field. Thank you so much for sparing your time. So a moment of value.
Thank you very much, students.
Good work, see you. चलिए फिर बांध